going to start just by doing a quick sketch of the situation. Just a quick sketch. And the first mass is going directly east. And it's going directly east at 10 meters per second. We don't know what the mass is, so 10 times 1, let's say 10 units. Units are, doesn't matter. The second one is angling down at about 40 degrees. I'm going to approximate that. And a little longer than that goes for 12. So that's 40 degrees right there. My unknown piece is going to go somewhere up here. I'm really not too sure where, so we'll find out. So my first diagram here is a diagram representing the situation. The diagram to analyze it, well, let's do a sketch to analyze it first. We have to have a tip-to-tail diagram. So 10 units to the right, east. Second momentum, tip-to-tail, and then down at 40 degrees. 12 units long, and 40 degrees. So my unknown here, just like the unknown here, is going to be somewhere like this, and up to the right. There's my unknown. Okay. So drawing these can help me decide what the answer is going to be in a ballparkish way. It's going to also help me draw a nice scale diagram. So here's some sketches, and now a scale diagram. So for the scale diagram, I need my protractor and ruler. I need a good Cartesian grid to start with. Make sure nicely right angles like so. Make it perfect. Like that. Yes, and of course north is still up there. That's the intention with that. Okay, now we need 10 units out to the right. But 10 centimeters be a bit too big for my paper here. So I think I will go with 5 centimeters. That's half that value. So 10 for the momentum, 5 for the unit of length here, okay? So an arrow 5 long, that goes right to there. Now I like to press straight down on my pen there, make a little divot, a little hole. That way my pen can find that proper spot again real nicely next time I need it. So we're going to be 5 centimeters. So I put my protractor down. It's going to be a tip-to-tail diagram, so I'll put it right there. And it's going to angle down 40 degrees. So that gives me a mark right there. Yeah, there it is. Okay. Now I need this to be 6 centimeters long. 6 centimeters to match the 12 units of momentum. So 6 centimeters long. I'll get my protractor going in the proper direction here. Like so. And 6 is right there. Stop at 6 mark. Place a nice divot to help me find it again. Like that. Wonderful. Now, my resultant vector is going to be, again, tip to tail. So from start of the second vector all the way to the beginning, the origin there. There it is. There is my unknown. Now I can measure the length of that without too much difficulty. Just put down that ruler, and with that I'm gonna see, about 10.41, let's see, 10.41 centimeters. So my first vector was 5 centimeters, my second vector was 6 centimeters, my unknown 10.41. I need the angle on it though, and you can't just sort of measure an angle like this. So I'm going to have to add some information in there. How about like this? Okay, put the pen in that little divot. I gotta align my protractor with this x-axis. Align like that. Everything is nicely at right angles then. And now I can measure this angle. This is the angle I want here. That's what I want. Yes, so let's measure this angle that I want there. And align the protractor, make sure it's aligned nicely. Lines. And there's the 20, 21, just above the 22 mark. Maybe 22.1, let's see. 22.1 degrees. So, answer-wise, I need to multiply this distance of centimeters by 2, of course, because of my scaling. So 10.41 times 2 equals, that's 20.82. 0.82. That'd be units of momentum, but because all the masses are 1, it's also the meters per second. So then it looks like my answer here, let's say to 3 sig digs, is going to be 20.8 meters per second, 22.1 degrees, and that's going to be north of west. And we're done.